Picture this. You've got a beautifully memorized, textbook-perfect explanation of the Kelvin cycle ready to go, but it actually costs you the A star. No way, right? Well, yeah, you can have every single biological definition memorized flawlessly. But if you just offer up a generic explanation, instead of linking your knowledge to the specific data in your exam paper, you're going to lose critical marks before you even finish that first sentence.
Welcome to this explainer. Today we're looking at the Kelvin cycle and elite exam strategy. We're going to completely demystify the core components here: Rubisco, RUBP, GP, and TP. And we're not just looking at the biology. I'm going to give you the exact examiner frameworks you need to secure top band marks in your Cambridge AS and A-Level Biology 9700 exams. We're transforming how you look at the cycle so you know exactly what the mark scheme actually wants.
Okay, let's dive right in and simplify the core concepts step by step. First up, Rubisco, the crucial enzyme that catalyzes the initial fixation of carbon dioxide in the Kelvin cycle. It's the ultimate catalyst. Fun fact, it's actually considered the most abundant protein on Earth, even though it's notoriously slow and kind of inefficient. But for your exams, when you see Rubisco, you need to instantly recognize it as the foundational trigger. Without Rubisco doing its thing, the entire cycle just halts.
Next, we pair Rubisco with RuBP, or ribulose bisphosphate. This is the 5-carbon acceptor molecule that binds with carbon dioxide. It's the vital acceptor that actually grabs onto the CO2 during that initial fixation phase we just mentioned. Basically, this pairing is what kicks off the whole transformation process inside the plant.
So that immediate reaction produces GP, glycerate 3-phosphate. This is the very first stable 3-carbon intermediate compound formed in the cycle. This is incredibly important. When examiners ask you to trace the path of carbol, identifying GP as this first stable intermediate is absolutely essential for your answer to actually hit those scientific accuracy marks. Finally, through reduction, we get TP, triose phosphate. This is the 3-carbon sugar used to regenerate RUBP and build organic molecules. Think of TP like a biological crossroads. It has 2 main pathways. A big chunk of it gets used up regenerating RUBP to keep the Kelvin cycle spinning, while the rest gets siphoned off to build the plant's actual organic molecules like glucose, amino acids, and lipids.
And this brilliantly illustrates the whole continuous, logical flow. Step 1, carbon fixation with Rubisco and RUBP. Step 2, reduction, where we form GP and then TP. And step 3, regeneration, where TP cycles right back into RUBP. It's a closed loop, and you must be able to describe these phases sequentially to lock in your marks. Understanding this progression, that's the literal foundation of high-level biological analysis.
Now, what is the exact phrase examiners look for to award the final mark? Well, in just a second, I'll show you the specific clue that transforms an average answer into a top-band A-star answer. It's a really subtle shift in wording that examiners actively scan for. But first, before we drop that clue, we need a framework to avoid the biggest traps students fall into year after year.
So, the key here is steering completely clear of these top 3 exam mistakes, straight from the Cambridge Principal Examiner reports. Number 1, confusing cause and effect in the cycle. Number 2, forgetting to check your units and terminology. And number 3, which is probably the most damaging, providing answers that are not specific to the context given.
Listen closely to this examiner quote. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Regurgitating textbook facts without integrating the provided data is a guaranteed way to lose points. If they give you a scenario about a plant in a high-light environment and your answer just generically describes what GP and TP are without mentioning that highlight, you are leaving major marks on the table.
Okay, let's look at section 1, the method mark strategy. This is all about securing partial points through process. Examiners will actually award you marks for demonstrating the correct scientific process, even if your final calculation is slightly off. The whole architecture of this topic relies heavily on systematic analysis. Basically, you get rewarded for thinking like a scientist. Whenever you face a complex Kelvin cycle problem, like maybe an experimental setup or a data table, use this framework. Step 1, deconstruct the given information. Step 2, solve systematically in logical steps. And step 3, evaluate by checking reasonableness. Doing this guarantees you're showing your work exactly the way the mark scheme demands. Part of solving systematically means interpreting data correctly, right? Always extract data carefully from tables, double-check your units, and apply the correct statistical test. Use the t-test for comparing means, chi-squared for categorical data, and a correlation test for relationships between variables. Knowing which test applies to the data is a massive advantage on exam day.
Let's do a quick active recall challenge. Spot the error here. TP is used to make glucose and RuBP. Go ahead and pause this explainer right now and tell me exactly why this generic student answer fails to score the higher evaluation marks. Think about the examiner reports we just talked about. What is missing?
What's really interesting here is the contrast. The flawed answer is technically true, but it's just a generic fact. Now look at the top band answer. In the highlight scenario, increased TP production rapidly regenerates RuBP, accelerating CO2 fixation. See how it actively identifies the causal relationship? It uses comparative connectives and provides context-specific evidence. That is exactly the phrase structure examiners want to see. It links the concept directly to the data scenario.
This visual formula right here is your ultimate weapon. Start with the core concept, like Rubisco or TP. Connect it immediately to the evidence or data provided in the prompt. Then apply scientific reasoning to explain why that data looks the way it does. And finally, wrap it all up in precise examiner wording. If you follow this exact flow, your answers are going to be virtually bulletproof.
But what if you misread the very first word of the exam question? We've just fixed how you explain the complex mechanics of Rubisco and TPR. But there is a hidden trap that causes brilliant students to give the absolute perfect answer to the completely wrong question. And it all comes down to the very first word on the page. I'm talking about command words. Explain, describe, calculate, evaluate. Understanding the intricate biology of the Calvin cycle means absolutely zero if you confuse an explain prompt with a describe prompt. If you describe a graph when the examiner asked you to evaluate the setup, your mark band is strictly capped, no matter how good your biology is. It's a fatal mistake.
So, your mandatory next step, master the command words. You really can't afford to lose marks over this. Next time you look at a complex biology question, ask yourself, are you just seeing textbook facts, or are you seeing a high-yield puzzle waiting to be deconstructed? Master that difference, and you master the exam. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, and click the next explainer right now to discover the exact command words that decide your final grade. See you there!